Okay, let's say we have a ring and we put a Q coulomb of charge uniformly distributed around this thin rings. Now we want to know what is the electric potential at this point at some distance x on the axis of this ring with a radius of r. Okay, so the radius of the ring is r. So what I will do is I'll pick a little tiny dq, a little tiny d charge here. It's from the center, its distance is r. I can calculate what is the effect, what is the electric potential due to this little tiny dq at this point. I only need to know what is the distance between them. Let's call this one r small. And so this lowercase r can be calculated from this x squared plus r squared. Remember that this axis is perpendicular to the ring. And so this r, if you move around this dq into different places, the only thing it's changing here is technically the angle changes from 0 to 2 pi all around the ring. The r is fixed, the x is fixed, and so the lowercase r would be also a constant number. And so the little tiny electric potential at this point due to this little tiny charge would be a constant k dq divided by the distance between the charge and the point of interest. So if I take an integral over dv to create the entire ring, then I will have the effect, the potential, the electric potential at this point at distance x on the axis. As you can see, dq is independent from x and r, and so it comes out of these k and r will come out of the integral. So you will have k dq divided by r. K is constant, r is constant. They come out of the integral, and then you will have integral of dq over the entire ring. Now, this integral is easy. This the summation of all the charges on the ring, which is technically the total amount of charge on the ring. And so at the end of the day, you will have the potential, electric potential at distance x on the axis would be k q divided by r. That's exactly what we expected, except we know that the r is root square x2 plus r2. Mix them together. You will find that the v sub x would be kq divided by root square x2 plus r2. Now here's a simple case. If x goes to infinity, means you're very, very far away from this ring of charge. You're expecting the entire ring to be seen as just one single point, and so this you're expecting to be independent from the r. And obviously when x is very, very large, you can conclude that x2 plus r2 is the same as x2 because x is very large. And so you can conclude that v sub x, v as a function of x is kq. Root square x2 would be the value of x. Okay, that's one step. The second step is when you are right between, let's say, at the center of, if you want to know what is the potential right between the ring, right at the center of the ring, that's when x is equal to 0. That's the center of ring. Then in this case, voltage or electric potential at x equal to 0, the center of the ring would be kq divided by root square r squared, which is kq divided by r. Okay,